Hello everybody and welcome back to episode 30 of the video series in which we program an entire video game from scratch in the C programming language using practically no engines and no libraries, just our brains and C programming. Alright, last time, what did we do last time? I forget. We talked a little bit about, oh that's right, we worked on this whole aspect ratio problem and we worked on the options screen. I'll go ahead and start that up. I feel like those screen transitions might be a little bit too slow, but we worked on this screen size issue, and it's working pretty well. Now, granted, we have a full screen only game, but we can change the screen size at least. We can change it, cycle through basically any 16:10 aspect ratio resolution until we run out of monitor size. If we wanted to do a windowed, if we wanted to convert this into where the user would have the option to change it from full screen to windowed mode, which I think we should do at some point. It's in the name of like quality and polish for the final product. It's always nice to let the user have more options because, frankly, people don't want to play this game full screen whenever they have other windows in the background. Maybe they want to keep an eye on their email at the same time, stuff like that. Although kids these days, I don't think they even do email anymore. It's just old guys like me talk about email. I don't know. You probably have like some apps, some TikTok, Instagram stuff going on back there. Anyway, right. So I do eventually want to convert this to a windowed, to have the option to go windowed, but to do that is going to involve a little bit more effort because you see what we're going to have to do is we're going to have to take into account where exactly the window is because we can no longer assume that the window size matches the monitor size. So we have to know exactly where in terms of both relative coordinates and like absolute coordinates. We have to determine where the window is so that we can draw the buffer in the right place, right on top of the window. And then when the user drags the window and moves it to the other side of the screen, we're going to have to recalculate and keep up with all of that. So we're going to do that eventually, but not today. Today, what I want to do is I want to fix this sound effects and music volume thing because this is not it's not saving correctly. See, notice right now the sound effects volume is on 1. And if I move it to if I ramp it all the way up to 10, and by the way, I have my own speakers turned down, so I noticed on the last video the sound coming from my own PC or from my own speakers was so loud that it was echoing back into the microphone, and I didn't like that, so I turned my sound down. Anyway, so I have the volume set to 10 there, the sound effects volume set to max, right? So I back out, I exit, and then at that point, when I hit the back button, it should have saved the sound effects volume to the registry. But now when I go back, you'll see that it somehow reset itself to 1, and I don't know why. So we're just simply going to debug that. Now if I look here, I think what I should do is I should probably go to save registry parameters. And I'm going to insert some logging here. Saved. Let's see. Oh. And I set SFX volume. And let's see. Music volume. And finally, scale factor. Right. All right, let's see what happens. All right, save 10. Okay, so the issue is that this D word, we assumed that we were going to be dealing with the sound effects volume on a scale from 0 to 100. And I think over here in save registry parameters, I'm assuming that we are going to be dealing with sound effects volume and music volume on a scale from 0 to 10. So we're off by a factor of 10. That would explain why there's an issue. All right. So what if we did this? And just for good measure, I'll delete these things from the registry. Okay, I set them to a value of 10. They're still at a value of 10. I'm going to set them to 0. They are still at 0. I'm going to set them to 1. They are still at 1. So it looks like we have fixed it. set them to 5, and they are still at 5. Okay, that bug has now been fixed. Delete that. Okay, shadow effect for text is, I don't think we're going to implement this today, but it is something I would like to do eventually. And it's also a really interesting topic, I think. There are a few different ways that we could handle it. And to demonstrate, let me go to this repository and look at this font. So what do I mean by shadow effect? Well, simple. Install when I exit, I guess. What I mean by shadow is, what if we did this? Canvas size. What if we changed it to be, I don't know, something wider, but then like 1 more pixel larger. Okay. And then let's take a gray color like that, and basically just kind of like fill in maybe here too. Yeah, something like that. And then, you know, on here we could do something like this. And essentially that isn't, you know, perfect, but that shows off the idea that I'm going for, where we have this basically a shadow effect underneath the text, and it looks better. It looks a little more polished. Even the Nintendo, even the original NES usually had sort of a shadow effect underneath their text. It looks more polished, and it has the bonus of allowing the text to stand out on almost any background color. Like, for example, if I put this black text on a black background, you wouldn't be able to read it. But if it had a shadow outline, you know, any sort of like outline effect, or even like a gray shadow effect, you would still be able to read it, at least, you know, at least mostly. But anyway, there's a number of ways we could handle this. This is kind of an interesting problem that I was thinking about earlier today. We could either create an entirely new font sheet, exactly like we're doing right now, or we could do it at runtime. We could add the shadow effect at runtime. And if we add the shadow effect at runtime, there's a couple ways we could do that. We could either basically, let me go ahead and close this and don't save it. Yeah, okay, fine. It's paint.net has to install an update. Okay, so there's a couple ways to do that. If we went to blitzstring to buffer, we could do every blitzstring to buffer twice, like this. Debug text buffer G 6x7 font, and then we can make some gray color. It's like 0, 6. And then the coordinates would be something like 1 and 1, right? So we're going to draw the text. We're going to draw the text once. at an offset of 1 pixel in and 1 pixel down, and then we're going to draw over it again in white, backing up 1 pixel and up 1 pixel. So I guess we'll just see what that looks like. And this is only there, the FPS raw column. Now that solution looks pretty good right there. If you look just at the first line that says FPS raw, I've given it a shadow effect just like that easy. And it looks pretty good. Maybe not perfect, but pretty good. The downside to that, though, the downside is tons of wasted CPU cycles, because most of these gray pixels are just going to get drawn over the top of when we draw the foreground, the white string of text over the top of it, and that sort of like is a rock in my shoe or a pea under the mattress, because I would just, even though, I mean, obviously our computer is fast enough to handle it, but what if we were doing this on a really slow computer that may not be efficient enough? So be thinking about that. There might be other ways. I was thinking of a way that we could actually enhance the blitz string to buffer function so that it would take a true or false of, do you want to shadow this or not? And if the user supplies a true, then give me a shadow color, and then during our blitz string operation, we'll actually just make our string bitmap a little bit larger to accommodate the shadow. And but then we would have to come up with some sort of algorithm of, how do we know which pixels we should paint as a shadow or not? We'd have to come up with some sort of algorithm, because you can't just paint every pixel that I don't know. It's definitely a problem that probably has a really cool solution. So stay tuned for that. Anyway, we are not going to be finishing that today, but it's on the to-do list. Should we enhance blitzstring to buffer to support var args? That's another interesting one. And what var args are, right? It's just like in printf, and it's just like what we've already done with the log message function. Variable number of arguments. It supports a variable number of arguments so that you can give it format specifiers just like you do with printf, and basically it would make the blitz string to buffer function a lot more convenient, but it would also cost CPU cycles. It's just like how many FPS are we willing to sacrifice in order to have that convenience? And that's really kind of what this entire channel, this entire video series is all about. Is that this sort of programming at this level is becoming sort of a lost art, because it seems like these days everybody wants to use Unity and C# and Java and these languages that are super high level, and they give you a lot of convenient features. No question about that. They do give you a lot of convenient features. But what I'm trying to show you as a counterpoint is that all of those convenient features in those higher level languages come with a cost. Every single one of them comes with a cost. And don't ever let anyone tell you that, hey, you can use XYZ programming language and it will do all these things for you and it's just as fast. It's never just as fast. There's always some cost hidden somewhere. The brute fact is your CPU has to execute CPU instructions, and each CPU instruction executed takes an amount of time. So when you execute more CPU instructions, it takes more time. and the net result is you end up with a program that runs slower because it's doing all these things for you in the background, which may have a lot of positive effects. Like it may be doing a lot of memory checks and safety checks and things like this that, you know, do have a desirable result. But they also come with a cost because there's always things going on. Your CPU is always executing stuff that you don't know about. You know, even when you write C++, you know, and C++ is just one step up from C, right? It's compatible with C, and it can be C++ can be used in a very low level way, just like C can. However, in C++, you have things like, you know, you create an object and it has this new keyword, right? And when you run this new keyword, it instantiates a new, it creates a new instance of this object. It creates a new thing, right? And what that's really doing is there's no magic here. It's just running. It's executing the constructor for this object, and this constructor does all sorts of stuff. It allocates memory. It may do all sorts of. It can do any sort of initializing that the programmer wants it to. And you, as the developer, when you're using these objects, you have no idea what all it's doing. All you know is that you get a new thing, but you have no idea all of the initialization that went into creating that thing. It's opaque to you essentially. Um, but enough of that. I mean, I'm telling you guys stuff you already know, so I'm gonna move on. So again, I'm gonna leave that there because I'll think about it. Character naming screen. That is the next place we're going. So I want to go to process player input title screen, and I want to go to actually menus, title screen, start new game. That's where I want to go. Menu underscore title screen underscore start new, which should already be here somewhere in here somewhere. Start new. There it is. All right, so there is going to be like, if a game is already in progress, this should prompt the user if they are sure that they want to start a new game first and lose any unsaved progress. Otherwise, just go to the character naming screen. And so we'll have to come back to this, but for now we're just going to set, actually let's make sure set, alright, so G previous game state equals G current game state, and G current game state equals game state, I can't type, game state character naming. All right. This is going to be, all right. So here's the here's the thing. This is going to be a big messy menu that we're about to create here, because we're essentially going to be creating a menu, and where every menu item is a letter of the alphabet. So we're going to have capital letters, lowercase letters, back, okay. I'll show you an example. And let me go ahead and start this. I keep going back to Dragon Warrior since that's sort of the game that we're trying to emulate here for the most part. Let me fast forward through this menu. Through this title screen, sorry. Title screen. There. That's what I want to make. I want to make this. I want to make this right here. So I think this is actually a good time to start breaking things up into multiple files. Since, I don't want to, do I really want to clutter? Maybe. Alright, so I drew out this little picture here of what I want it to look like. This is essentially what I want my character naming screen to look like. And to do that, we're going to have to create all of these little menu items. Each one of these is going to be a separate menu item, each with its own XY coordinate and its own function pointer and all this kind of stuff. For the sake of cleanliness, we could potentially point all these to the same function and just sort of infer based on the position of the cursor which character the player currently wanted to append to the character's name. I don't know, I'm really thinking out loud here, but we gotta get started. Gotta start somewhere. So we're going to call this GMI character naming capital A, and so it begins. So the name of it is going to be capital A. The position of it is, I don't know, I'm just really sort of guessing. We know that each one of these characters is going to be 6 pixels wide, but we also need at least 6 or possibly 7 pixels spacing in between each character for the cursor, right? Like that space in between each character. I have no idea how we're going to center the whole thing. We'll probably just have to center it later. We can add all these up. We could add all of these things up and do the arithmetic necessary to find where the exact center of the screen is. But for right now, I don't care. I'm just going to start it at 100 x coordinate and a y coordinate of 100. We'll just start there. We've got to start somewhere, right? And then we need enabled is true, and menu item character naming add. So this is the part where it's like I could make a separate function pointer for each one of these, basically a separate function for every single letter, but no, I don't think that's a good idea. I think I'll just leave it at that. I'll make the same function pointer for every one of these letters. B, and so this one is going to be I guess 10 pixels that away. I have no idea what this is going to look like. ABC, 10 more pixels. E, F, G, H, I, J, K, L, M. Okay, A, B, C, D, E, F, G, H, I, J, K, L, M. And let's see, 100, 110, 120, 130, 40, 50, 160, 170, 180, 190, 200, 210, 220. Let's make a function declaration here, and then we will go create the function right there. Right. B, C, D, A, B, C, D, E, F, G, H. Yes, I was singing the alphabet song there for a second. So J, K, L, M. Alright, that should conclude our first row of characters. Let's go ahead and make the next row of characters. This is going to be N through Z. N, M, N, O, P, Q, R, S, T, U, U, V, W, X, Y, Z. N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now, I can think of one thing that does kind of suck about this is, it locks us into English only, or the Roman alphabet, which we were already basically locked into on account of the font sheet. There's just not going to be Unicode. I doubt that this game will ever get to a point where we feel like we should be translating it into other languages. Although, for the record, I do feel bad about that. I would like to be inclusive, but, you know, translating things and localization is just not something that I've ever messed with before, and it's not something that I really want to tackle right now. So we may think about it way down the road, but not today. Anyway, so we made our second row of characters. These need to be the same X positions, but they all need to be lower Y positions. So again, without really having any clue, I'm just going to arbitrarily move these. Move these 10 pixels down. 110. X and Y. And I'm already messing up here because this is the first row. Should all be at 100. And this should be at 110. This is the second row. come to the third row, which is going to be just like the first row, only lowercase. And as you can see, the variable names are case sensitive, so it's okay for me to do this. A, B, C, D, E, F, G, H, I, J. Oh, you know, speaking of Unicode, you can also use Unicode in your variable names. Character map. For example, if I want to put a sharp S in my variable name, I totally could. There's nothing wrong with that other than that it's confusing. But I mean, it's totally technically allowable, at least from in Visual Studio. You could make it a smiley face. You can make it a whatever symbol you could find. Doesn't have to be, your variable names don't have to be restricted to only ASCII symbols. And in fact, I thought about doing that back over here in WinMain when I was dealing with microseconds. I could actually have replaced the word micro with the little micro symbol, and it would have probably looked pretty cool. But in the end, I decided that I would just spell out the word micro because it would probably be pretty confusing for someone else who wanted to read the code too. Anyway, let me finish what I was doing here. L. Okay, and this is going to be $120, I guess. Y coordinate of 120. Okay, one more row. It's going to look just like this, only lowercase. U, V, W, X, Y, Z. Z. Okay, and this will be one. This will be at 130. 130 Y coordinate. Okay, now we need two more for back and OK. Menu item, character naming, back, menu item, G, character naming, OK. it's going to be at the same, our back is going to be at the same x coordinate as the first letter, so it'll be at 100. It'll be at 100 and 140 down, true for enabled, and menu item, character naming, back, which doesn't exist yet, but we'll make it. Now, the OK button will be at it'll be at the same x coordinate as the last letter, so 220, and then y coordinate 140, true for enabled, and menu item, character naming, OK. Let's go back up here, make these functions. Okay. Let's go to menu item, character naming, add. Void, back, and okay. All right, we're getting there. Now, what we need to do next is create the array of menu items, just like that, which is going to be super annoying, but we're going to do it. Menu item pointer, GMI, character naming. And make sure and get the naming convention consistent. GMI underscore items. Yeah. Items equals. And here we go. GMI character naming A. B. I didn't get the ampersand in there. Oh, come on. C. D. E. F. G. H. I. J. K. L. M. Whew. I'm just trying to fit them all on the screen right now is my only concern. Drink of iced tea. A, B, C, D, E, F, G, H, I, J, K, L, M. Let's keep going. N, O, P, Q. Oh, come on. R. What is going on here? What is going on here? I don't know why it's doing that, but it is very annoying. Okay, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. Why are you doing that? It's very frustrating. U, V, W, X, Y, and Z. Copy. Wow, it messed up every single one of these. I don't know why Visual Studio wants to put it just really wants to put an ampersand, a space between the ampersand. Yeah. Always wrestling with Visual Studio. You know, I've been apologizing for Visual Studio this whole time. It still does a lot of stuff that really annoys me now. Anyway, back to the lowercase letters. We'll just have to do this meticulously, one at a time, because copy and paste is not something that Visual Studio has in its wheelhouse. But that's okay, you know, we will deal. We will persevere. If you write C, if you program in the C programming language, that automatically tells me that you are not the kind of person who gives up easily. M-N-O-P. I bet that this is not what you thought you were going to do today, was watch some guy on YouTube sing the alphabet song. Q, R. We're almost done. S, T, U, V, W, X, Y, Z. And finally we need back and OK. G and I, character naming back. G and I, character naming, oh my lord, character naming. Okay, we're done. Next thing we need to do is we need to create the menu, or I should say the last thing we need to do here is create the menu itself, which is a menu, and it's going to be called gmenu underscore character naming. And the title of this menu is going to be, what's your name, hero? I just made that up. It's pretty cool, huh? Initially, it was going to start on the 0th element of the menu. The number of menu items is going to be count of GMI character naming items. And the finally, we just need this pointer to all of those items. Character naming items. Okay. Wow, that was rough. Let's go now to render frame graphics. Render frame graphics. Let's make sure that we have a case for it. Here it is. If the game state is game state underscore character naming, then we need to do draw character naming, which does not exist yet. So let's go create it. Here we go. Draw character naming void. C. Go to all these draw functions. Try to keep them grouped together if at all possible. Okay. Now I'm going to set this up the same as all these other functions because I'm going to have the same sort of fade in effect, which the more I think about it, the fade in is kind of slow, isn't it? I maybe should make the fade in a little faster. You can basically copy all this stuff because it is going to be identical. It's going to fade in. So I can copy this stuff too. Character naming. Copy paste. Copy paste. Except, except this part can go away. And we're not resetting the title screen menu, we're resetting the G menu character naming dot selected item equals 0. Alright, and remember this is for the situation where if we have left the character naming screen at some point and come back to it, we want to make sure and reset all of the state of this game state back to its default so it starts over. Right. Alright, I think we're ready to start drawing. 4. Counter is less than G menu character naming dot item count counter plus plus. We are going to draw all of these things using blitzstring to buffer. We are going to draw G menu character naming dot items index counter. Name. Yes. And we are going to draw it using our good old buddy font sheet, 6x7 font. The color is going to be text color, which is a local variable. And then X is going to be, I already know this needs to be on a separate line. G menu character naming dot items index of counter X. And then the Y coordinates of Y. Bingo. Finally, we need to draw our little cursor, which I will go copy from here. Matter of fact, I'll copy this right out of here. Okay, I'll accept changing this from title screen to character naming. Character naming, X -6, because remember the cursor is like set back a little bit to the left. Character naming. Character naming. See what our time is looking like. Oh, we're almost at an hour. Will we finish? Okay, so keep in mind that I have not yet implemented the process player input function for this game state. So let me go to process player input. Make sure that we have a case for this game state. Here it is right here. PPI character naming. We need to go make that function. PPI character naming. And then we need to define it in our C file. PPI. Okay. Let's go back to draw character naming for a second. Now, here's what I think is going to happen. I think that this is correct, except I don't know if the X and Y coordinates are going to be, I have no idea what the X and Y coordinates are going to look like. So I'm going to try to get it centered in the middle of the screen. That'll probably just take a little bit of trial and error. Or I could be smart and like add up the number of items plus the space between each item divided by 2 minus the entire screen divided by 2. You know, that same sort of algorithm that we've done dozens of times. Now keep in mind that I don't have the process player input implemented yet, so I won't be able to select through here, but I just want to see what it looks like first, okay? So let's run it and see what it looks like. Start new game. All right. That is not bad. Not bad for a rough draft. Of course, now we're stuck here because I don't have the input implemented, so I'm just going to right-click and quit the game. Okay. Now, what did we learn? We learned first I need to split string to buffer. Gmenu character naming dot name, and sheet is going to be 6x7. The color is going to be text color, and then the X is going to be the X is going to be game res width divided by 2 minus the string length of gmenu character naming dot name times 6, because each character is 6 pixels wide, divided by 2, right? And then we need a y coordinate as well, which will be 90, I guess. X and Y, everything good, everything good. All except for I'm going to put an extra set of parentheses right here. Alright, so I think that should center that in the screen. Let me go look at it. I said, let me go look at it. Okay, what is your name, hero? Alright, so there are a couple more things that I want to add to this screen. Other than obviously, I want to get this stuff centered. I want to get it laid out a little nicer. Um, these probably need to be spaced out a little bit more because the cursor, I can already tell there's not enough space between each letter for the cursor. So they need to be spaced out a little bit more. I also need to I think I want to probably draw like the player sprite up here with like some underscores next to his picture where the name will go, and so the name will show up as you input on this menu here. So we still definitely have some work to do here, and I will definitely work on that. But we are at an hour, so I'm going to have to call it for today. We did make some progress though. That was probably the gnarliest menu that we are ever going to have to make. Now there are, other games like take for example the Final Fantasy games where you throughout your adventure you encounter multiple characters and you have these characters in your party and it gives you the opportunity. The game gives you the opportunity to name each and every character in your party. We may want to do that at some point, but then again, we may not. If we decide to keep it simple, a game like Dragon Warrior or Dragon Quest, you only have the one character, and so you name that one character, and that's it. So we may just decide to keep it simple and do it like that. Haven't decided yet. Um, But regardless, this is where we're going to pick up next time. We're going to finish implementing this character naming screen. And then once we finish naming our character, we're finally going to go back into the overworld where we can walk around with our character finally, our freshly named character. And, we'll get to draw like a tile map with like mountains and grasslands and forests and things like this. It's going to be great. Um, but that's all for today. So, as always, thank you very much for watching. If you want to see me finish this game, please like and subscribe. And if you have any questions about any of the programming that we have done for this entire series, please, don't hesitate to leave comments and questions on the videos. It doesn't have to be about this video. You can leave comments on any of the videos. I will talk about those comments and questions in an upcoming episode. Also, don't forget that we have a companion GitHub repository to go along with this that I keep updated with each episode so that you can go and clone the GitHub repository and follow along at home. And so with that, I bid you adieu. I will see you in a few days. Thank you for watching. Bye.